Uh, we would like to turn this afternoon over to Scott, and we are so grateful and excited to be learning from one of the experts in this field. Scott, welcome. Thank you for being here with us in the camp.
Scott is muted.
Okay, there we go. It wasn't allowing me to unmute, but now I've unmuted myself. So can you guys hear me?
Yes, excellent.
Hey, perfect. All right, well, great. Well, thanks, Wendy. And thanks for having me here tonight for me. And I guess, well, it looks like someone from Bob B. Apiary is in Hudson Valley. Bob, I'm also in the Hudson Valley right now. I'm actually up in Poughkeepsie. I'm in a hotel room. So I guess evening for us and maybe late afternoon for most people on this call if you guys are mostly from California. All right, so let's see if I can figure out how to share these slides. There we go.
Terrific.
How about that? Can
Yeah,
everyone see
that's
that okay?
beautiful. Thank you.
Perfect. Okay, I'll minimize you guys so I can see what I'm talking about here. All right, so yeah, thanks again for having me and uh, asking to me, I guess, to talk about pesticides and bees. So this is probably the topic that I'm asked to talk about most nowadays. Um, we're, I don't know, sort of reluctantly becoming experts on pesticides and bees the more that our lab works on this. So I'm going to talk a little bit about some of the science behind bees, and then we're also going to talk about some of the practical applications, for this topic, because I think a lot of people are interested in both of those things. So number one, what do we actually know regarding pesticides and bees? And then number two, if you actually want to try and do something about it, what are things that you can potentially do? And I'm certainly not going to solve all of those problems, but I will talk about a few things that our lab has done and potentially, anyone in the public can potentially do if you're interested. All right, so to get us started, there we go. All right, so the people that are involved in this are going to be featured here. And one is Tobias Mueller. He's a PhD student in my lab. David Sosa is a former lab manager. I just lost him. He went back to Colombia and he's a stingless beekeeper in Colombia. So I just lost him, unfortunately. He was a wonderful lab manager and has been working in our core facility for several years, which I'll talk about in a bit. Angelica Sanchez is a postdoc from Brazil, really good toxicologist and good at using the fancy machines as well, which we'll talk about. And then Christina Zhao is a technician in our core facility. Wayne Anderson over here, I don't know if you guys can see me scrolling or not, but Wayne Anderson, you can, okay, perfect. So Wayne Anderson is our main pesticide chemist. His background is in his environmental chemistry. He's been a pesticide chemist for about 5 years now. Travis Grout is an economist, took lead on writing our large extension report where we talked about neonicotinoid insecticides and looked at economic benefits and also risk to bees in that particular report. And then Diana D'Souza, former postdoc who now works at BASF. So she went over to industry. Travis is in government and Diana is in industry. Okay, so those are the main players that we'll talk about today. But to get us on the same page about what we're talking about, let's start talking about what you see in front of you right here. So this is I think, a beautiful photo, which I've stolen from the internet. But this is just showing that bees are really messy, right? So this honeybee right in front of you here has all sorts of pollen on top of it. And this is really what gets bees into trouble, right? So they are excellent pollinators because they can transfer all of this pollen between a large portion of land plants. So we know that about 87% of plants are partially or wholly reliant on animals for pollination, primarily bees. And honeybees contribute about 50% of pollination services. All of the other bees and other insects and other vertebrates even are doing the rest of the pollination. We also know that it's not just good for nature to have good pollinators, but it's also really good for agriculture and the things that we eat. So I'm in New York right now, and I sort of think in New York terms oftentimes. So just showing you some of our major pollination dependent crops, this pales in comparison compared to what you guys produce out in California. But we're still proud of our New York crops. We're called the Big Apple State for a reason. So we produce about $320 million of apples every single year, and then we have a lot of other fruits and vegetables that we produce. Based on the reliance on pollinators for successful fruit production or vegetable production, we estimate that pollinators contribute about $400 million in services annually in New York across all those fruits and vegetables. Just to couch that in global terms, or US terms and global terms, pollinators are estimated to contribute about $15 billion in services annually in the United States, and they're estimated to contribute about $170 billion in services annually in the world. Both of these estimates are a little bit out of date, and we're in need of some more master beekeepers to come step forward and update some of these estimates for 2025. But needless to say, it's pretty large numbers. Pollinators are important for a lot of things. Unfortunately, we're losing a lot of pollinators. So I'm sure you guys, being in California, have heard about the current disaster that is going on with honeybee colony losses, which I'm happy to talk about later on. Our lab is going to be getting quite involved in that particular topic. But just showing data from really when the Bee-Inform partnership started taking data in 2008, expanded to really looking at annual losses in 2011, and then has been looking at this all the way until, unfortunately, Bee-Inform partnership went bottom up last year, and then this was taken over by Auburn University, Oregon State University, and Apiary Inspectors of America. We can see that there is troubling high levels of losses. So 30 to 55% of USA honeybee colonies have died each year since at least 2011. And if anything, we might even be seeing an upward trend in what's going on here, which is particularly disconcerting. Here in New York State, we put 4 years of effort looking into the status and trends of native pollinators. And this is something that was just published by the New York Natural Heritage Program, New York Natural Heritage Foundation. And this is the Empire State Native Pollinator Survey. Again, 4 years of effort. And what we find is that using conservative criteria, 38% of New York's native pollinators are at risk of being lost from New York or extirpation from New York. So not really good news for native pollinators as well as honeybees. Why are pollinators having problems? Well, lots of reasons, right? So I would say this is the scientific consensus that we had in about 2010, I would say, is when we really realized this was the consensus, but it's still the consensus today. It is no one thing that is causing problems for pollinators. It really is death by 1,000 cuts. So things like pests and pathogens, climate change, habitat, inadequate management practices, and pesticides are all important, especially for honeybees, this big varroa mite up here. I'm sure you guys as master beekeepers know that this is biological threat number one to honeybees. Fingers crossed it stays that way and triple ALAPs doesn't become biological threat number one in the United States. I'm sure you're talking about to other folks on that topic. But what we're going to focus, research topics in our lab, we do study multiple things other than pesticides, but what we're going to focus on for this evening's talk is pesticides. And like I said at the beginning, this really is, I would say, turning into the major focus within our lab. And I feel like I'm starting to be able to convey information that some other people can't convey. Just because of my particular knowledge on this topic right now. So hopefully I can share some of that knowledge over the next 45 minutes or so. All right, so here's the outline for the talk. We're going to talk about 3 major topics. So when is there exposure to bees from pesticides? The second is when is there risk? As you'll see from the exposure topic, bees are basically always exposed to pesticides, but when is there actually risk? That is the critical question. You know, I can be exposed to all sorts of environmental toxins all day long, but if it never exceeds levels that are actually causing harm to me, well, no big deal, right? So when is there risk? We're going to look at two metrics. There's lots of different metrics. I've just listed four of them here, but we're going to focus on two metrics for this particular talk of risk. And then we'll sort of finish up with you know, a little more spicy topic here, talking about information and disinformation in the public domain about this particular topic. I'm sure you guys have seen lots of stuff, you know, in the newspapers about this. There's people with lots of heated opinions here or there and elsewhere on this. I'm going to show you some of the stories from the science industry policy interface on this topic, possibly including someone who's on this call right now as I was looking through the names. We'll see if that person is actually on here or not. Okay, so let's start with when is there exposure? All right, so we'll start off with showing some data from our New York State Beekeeper Tech Team. This is a wonderful state-funded program that really helps beekeepers. And actually, my dad is an industrial designer. He's the person who actually designed our logo, which I really love. My understanding is there's at least talk within the Nino Alina's Bee Lab about potentially making a California beekeeper tech team, and I really hope that that's real talk and it actually comes to fruition.
Yeah, it's
Um,
happened. It's called the Bee Health Hub. So yes, it's
Wonderful.
happening.
Okay, great.
Yes. Yeah.
Very cool. Very cool. Well, anyways, I don't, that's a whole separate talk that I could give on our New York State Beekeeper Tech Team. I would love to interact with you guys some more if there's anyone who's interested in that, especially as you guys are starting your program out in California. I can show you, you know, what we've done in New York, maybe some lessons learned, you know, ways to make California be even better than New York. I know that's not possible, but you
Aw.
know, maybe sometimes.
Let's share information. Yeah.
No, it sounds great. So anyways, we've been running the Beekeeper Tech Team since 2016. So we now have 9 years of data on this. And I'm just going to show you one bit of data. So, oh yeah, so how do we get that data regarding pesticides? I also run something called the Chemical Ecology Core Facility at Cornell. This is available to anyone. So Wayne is our main excuse me, LCMS pesticide chemist. Danny Dreyer, I just hired her. She's our GCMS expert, really good environmental chemist. Christina is our technician, and Angelica is our postdoc. We have a 105 pesticide multi-residue screen right now, and we typically process about 2,500 samples per year. Maybe some people on this call have used it. If you haven't, you know, feel free. It's open to the public. Anyone can send us samples, and we're willing to process them for you. All right, so just showing you one publication from the New York State Beekeeper Tech Team. What we find when we look in colonies just year after year is that pesticides are in pretty much every colony. So they're in about 98% of colonies. And if you look across all the different scales of beekeepers, it varies from year to year. Sometimes hobbyists are more than like just depending on who enrolls in our program. Sometimes hobbyists are more, you know, have more pesticides than sideliners. Sometimes sideliners have more than hobbyists. Commercial beekeepers always have the most pesticides in the wax. So as you can see here, this is the number of pesticides in the wax right here. Commercial beekeepers were up around 22 pesticides in wax on average. And then across all operation scales, it's 17 pesticides in wax. This is typical contamination, you know, across all the years that we've done this study. This is pretty typical of all of the other studies outside of New York that have been published on this particular topic as well. All right. What about exposure during pollination? So here we're going to go to some data from Tobias Mueller. He's a PhD student in our lab who was looking at pesticide exposure to bees during New York State apple pollination. And you can see right here, here's a aerial sprayer spraying, you know, these particular trees right when they're in bloom. This occurs all the time, especially with fungicides. Fungicides are heavily used during bloom, especially in a wet place like New York that has a lot of fungal pathogens, things like apple scab, etc. Okay, so for this particular study, Tobias went out to 20 different orchards. He recruited a whole bunch of folks in our lab, myself included, and we went out with nets collecting all of the different bees that were out there. So you can see the locations. It was in the prime apple growing region of New York State. This is up on Lake Ontario. The other prime apple growing region is where I am right now, over here in the Hudson Valley. And then what we also looked at was mostly for convenience sake, just some orchards around Ithaca, New York, which is where Cornell University is. Okay. So we collected all these bees individually into vials and brought them back to the lab. This was pre Wayne. So we had a previous chemist, Nick Aubert, who moved back to France during the pandemic. He was a wonderful, chemist to have in our lab. But I think during the pandemic realized maybe the U.S. wasn't the place for him and moved back. But anyways, he is sitting in front of our LCMS, where we're doing a lot of the chromatography to quantify the pesticides. David Sosa, my former lab manager, who's now back in Colombia, did a lot of the bench work for this. All right, so what I'm showing you here is a heat map of all of the different pesticides that were in each bee. So in each column here, that's one individual bee, right? So this first column, is one individual Apis mellifera, or a Western honeybee, and you're looking at the quantitative levels of each of the individual pesticides in those bees, right? So this is a scale from 0 to 1,000 or so parts per billion here. When it's really light color, so like this yellow up here, that's not very high amounts, but at least presence of this particular fungicide. This is trifloxystrobin. Whereas if you're in a much darker color, for example, this one right here, this is a relatively larger quantity of an insecticide, chlorantraniliprole. All right. In general, we find that fungicides are the dominant pesticides that are in bees. Herbicides, we also find that bees are picking up during apple pollination. And we're finding a surprising number of insecticides as well, which is interesting because none of the growers involved in this study were actually spraying insecticides during bloom. So clearly these insecticides are somehow popping up from either, residues that are lingering or they're coming from somewhere else. And then we always screen for this insecticide synergist, piperonyl butoxide. This is one of the few data sets that has very little piperonyl butoxide. What we're finding over and over now, I don't know why, but piperonyl butoxide is showing up in almost every single sample that's coming into our lab nowadays. I think clearly something is changing in what people are using. And this synergist, which causes insecticides to become more toxic to bees, is showing up pretty much everywhere. All right, so again, just to orient you to this particular slide that I'm showing you with this heat map, which is obviously a lot of data that I'm showing you at once, but this is 6 different types of bees. So I showed you that, this is one bee of Apis mellifera. This is 20 different orchards that the one individual bee was caught in. Same thing for this mining bee here. So this is Andrena, a small Andrena. This is impatiens queens. So Bombus impatiens queens are big bumblebee that we see a lot here during apple pollination. These are Bombus impatiens workers over here, so one from each of the orchards. We actually put sentinel colonies of Bombus impatiens out in these orchards, which I'm not going to talk about here, but we also looked at performance of the bees in these different orchards. This is Melandrina, another species of mining bee, and then Xylocopa. These are carpenter bees. We didn't find Xylocopa in every single orchard, and you can see the width of these. There were some orchards where we didn't find some of these bees, but in general, we found almost one bee per every 20 orchards. Okay. In general, what we find is that there's 7 pesticides in the bees on average during New York State apple pollination. All right, let's go to one more study before we wrap up with exposure, and then we'll start talking about risk. So this is another study that I teamed up with Kelsey Graham, who's now at USDA IRS out in Logan, Utah. Megan Milbrath, who I understand is apparently out in California right now doing some sampling on something. She's at Michigan State University, and then Rufus Isaacs, who's also at Michigan State University. So we wanted to look at pesticide exposure during Michigan blueberry pollination. Here's all the data. Let me just orient you to it. So this was trapped pollen now. So now we're not looking at individual bees. I guess I started showing you the wax, right from all the colonies and the tech team. Then I showed you what's actually in the bees. Now what I'm showing you is trapped pollen. So this was putting pollen traps on the front of hives from either honeybees, that's what HB is in 2018, honeybees in 2019, or bumblebees. Kelsey didn't put a pollen trap on. She actually caught the individual bumblebees as they were returning to the hive and individually picked off pollen loads. I can't even imagine doing that, but apparently she turned into a pollen load ninja and was able to do it. So anyways, what I'm showing you here is there's quite a bit of pesticides coming in on these in the pollen that's collected by honeybees or bumblebees. In 2018, you can see here in either unsprayed orchards, organic orchards, or conventionally sprayed blueberry orchards, the average is somewhere between, what is it, 30 to 37 or so pesticides in that trap pollen, about the same in 2019. And then bumblebees have slightly lower contamination levels, so 19 pesticides on average. So what's the conclusion? Well, honeybee collected pollen of these particular, honeybees that are doing crop pollination for blueberry, 35 pesticides on average. Bumblebees, 19 pesticides on average. Okay, so the take home here across 3 different data sets that I'm showing you now, bees are almost always exposed to pesticides. But the real question again is, when is there risk, right? So is this just sort of trace amounts and, well, we shouldn't really worry about it? Or is there actually risk? Okay, so here we're going to get into 2 different risk metrics. And before I even start going down the metric route, I'm going to give you the answer. All right, so when is there risk from pesticides? Rarely during day-to-day beekeeping. We do find sometimes, people will send us samples from their day-to-day beekeeping where they notice something really bad happen in their colonies. We do get some samples that show extremely high levels of pesticides, but it's pretty rare. That said, it's actually fairly common during crop pollination, and I'll show you why. Okay, so let's first talk about pesticide risk. Pretty easy to define what pesticide risk is. It's just, the combination of exposure and toxicity. Did anyone have a cup of coffee this morning? All right. Did anyone have 2 cups of coffee this morning? So if you had 2 cups of coffee, your exposure to that caffeine was twice, so you probably got a little jittery, like you had some risk of having, a caffeine high because you increased your exposure. All right. How about this? Did anyone get up and do cocaine this morning? Hopefully not, right? So cocaine is just another alkaloid, right? It's the same chemical family as caffeine. But there is a reason why cocaine is illegal. And that has to do with the fact that it is way more toxic than caffeine, right? So even if you were exposed to the same amount, the same exposure of caffeine and cocaine, the same quantitative levels, your risk is going to be much higher if you used cocaine because of its toxicity, right? So these are the 2 things that you need to consider when considering risk: exposure, how much are you exposed to, and the toxicity of whatever you were exposed to. Pretty simple, right? All right. So there's multiple different ways to estimate risk. And these are 2 of the, well, actually, this is the same thing for estimating risk. This is using the hazard quotient or toxicity weighted concentrations. So one was one that I used in one original report I published on this particular topic. Toxicity weighted concentration is something that Charlie Nicholson, who is a former UC Davis alum, he did his PhD in Neil Williams' lab over there at UC Davis and just published a Nature paper, probably the seminal work, I would say, on this particular topic just last year. So what are these things? It's actually the same exact metric. So you just look at exposure in terms of what is the concentration in a sample. So if it's the concentration in pollen, for example, that is estimated as the exposure because the bee is probably going to be touching that pollen and the bee is also probably going to be eating that pollen. And then you just divide it by the LD50. So this is the measure of toxicity. This is a piece of data that we have a lot. We have for pretty much every single pesticide, because during the pesticide registration process at the EPA or in other countries at different, whatever they have for their particular regulatory agency, typically LD50s are required for a large number of non-target organisms, honeybees being one of them, as our sort of model model organism for terrestrial insects. Okay. So again, we can get this data. I've already showed you this data. This is concentrations in samples. I showed you it for wax. I showed you it for bees. I showed you it for pollen. And this data is available to us just because basically every pesticide that's out there on the market has an LD50. Okay, so it's a simple metric to do. And then finally, I've already showed you that pretty much every sample has multiple pesticides in it, right? So what is the simplest way to potentially summarize risk for all of those multiple pesticides? Just to add them up, okay? There's all sorts of assumptions that go into this, like should we be adding them up? Should we be multiplying them? Should we be doing something different? But the simplest assumption is just to add them up, okay? All right, so let's work through an example here. Let's go back to our pesticides in bees. This is Tobias's data set. So here's all the pesticides of all these different bees. This one column that I'm showing you here is the exposure profile for this one bee, this one Apis mellifera, this one individual bee. It had 7 pesticides in it, 3 fungicides and 4 insecticides. If we want to know risk, if we want to know risk, what we want to know is just, all right, what is the sum of the concentrations of those, and then divide it by the LD50s for the toxicity by each of one of those. What do we get when we do that? Well, we get this, okay? So this is now the same data plotted as a hazard quotient, so this HQ that I showed you before, expressed as a percentage of a honeybee LD50. So I like to use that as what I put on the y-axis, just because I think it's relatively intuitive, right? If you have an exposure that's at 100% of an LD50, well, that means that 50% on average of those honeybees are dying if you have that level. If you're at 1% of an LD50, all right, well, the pesticides are there, but it's probably not having a huge impact on those particular individuals. So what do we find? Well, we find a few things. Number one, you can relate things or risk via contact exposure LD50s or oral exposure LD50s, right? So both are relevant since this is bees that we're looking at right here. Clearly the bee is contacting the pesticide because it's in the bee. And clearly the oral is also important because it's in the bee, right? The bee probably consumed whatever it was, either that or it has it on the outside or potentially both, okay? We can also relate this to regulatory agency levels of concern. So the EPA, US EPA, puts this benchmark right up here at 40% of an LD50 is what they consider as an acute exposure level of concern. The EFSA, or European Food Safety Authority, is a little more conservative. They say 20% of an LD50 is acute exposure level of concern. And then EFSA also provides this 3% benchmark right here, where they say, all right, at 3%, if that bee is potentially exposed for 10 days, that could be a chronic exposure level of concern. Where are they coming up with the number 10 days? Out of a hat, right? Where are these numbers of 40% and 20% coming from? Also out of a hat. Like you could put any number on that. This just happens to be what these particular regulatory agencies say. Okay. What do we find? Well, there's 2 main things that we find from Tobias's study here. Number one, honeybees pretty frequently are above the US EPA acute exposure level of concern. So 56% of orchards are actually above that 40% threshold. I would say that that's a pretty notable result. If I was working at the EPA right now and I found out that All right, in this survey of 20 orchards, 56% of the orchards were above the acute exposure level of concern. I would say, kind of by definition, that's a level of concern that's been exceeded, right? But I would say the second major thing that we're seeing here is most of these wild bee species are below levels of concern. Not all, right? So there certainly are things, individual bees that are above these levels of concern that are stipulated by regulatory agencies, but in general, most of them are below. I'm not going to show you some of the fancy analyses for why this is taking place, but I am just going to point out right here what's driving it. So it's mostly high thiamethoxam levels that are in these honeybees, and that is greatly increasing the risk. Thiamethoxam is a neonicotinoid insecticide, and I'm happy to talk, about where that we think that might actually be coming from. All right, so there is the hazard quotient approach to assessing risk. Now I'm going to show one more approach for assessing risk. And this is something called the lowest observed effect concentration, or the LOEC. And really the question that this gets at is why, asking the question, why should LD50 be the measure of toxicity? Sure, it's available, right? So, we have that data because it's part of the pesticide registration process, but should we really only be worried about death of bees, or should we be worried about some other responses, perhaps some of the sublethal responses? I think this is what I'd like to, point out to everyone is, would you be concerned if something you ate didn't kill you, but it made it so you couldn't have children? Probably, right? I mean, I certainly would be concerned if, this soda that I'm drinking right here didn't kill me, but it made it so I couldn't actually have children. The same should be true for how we think about pollinator populations. Currently, the problem with pollinators is not just that they're dying, but it's that we're having problems with their populations. We have population declines of pollinators that are occurring, okay? What is population change defined by? It's defined by births and deaths. So this is, I guess I've showed you two equations now. I think this is the last equation I'll show you in this talk. And it's really simple. It's just subtraction, right? So your change in population, your dNdt, if anyone has taken introductory biology, is simply defined by how many births you have and how many deaths you have. And this is really intuitive, right? You have more children in your family grows. You have more grandparents that pass away, your family shrinks. Same thing for all populations, including bees, okay? What's important to convey here is that pesticides impact the ability to reproduce before killing bees. So this particular sublethal response is particularly important, okay? If we care about changes in populations, we should not just be considering LD50 values, we should also be thinking about sublethal responses, especially impacts on reproduction. All right, so we did do a formal risk analysis using this LOEC approach for something that was commissioned, or we were commissioned to do for New York State. So back in 2018, when Governor Cuomo was our governor here in New York State, we were commissioned to do we turned it into a 432-page risk-benefit analysis. We were commissioned to do a risk analysis for neonicotinoid insecticides. That administration wanted us to do side-by-side analysis of economic benefits and risk to pollinators in all of the major application contexts in which neonics are used. That includes field crops, so things like corn, soybean, wheat, fruit crops, vegetable crops, ornamentals, turf and landscape management, and also conservation and forestry, okay? So we did this, and I realized you guys might not want to read 432 pages, so just to show you that we also published a 4-page summary of this report. I think I'll probably just end up sharing the slides after this, or you can take a screenshot here if you're interested in seeing the 4-page summary. There's the link right there. And we did this in all of those different application contexts. I'm only going to show you field crops just because I don't have time to do everything in this particular seminar. So what I'm showing you here is how we summarize the data for risk to pollinators in this field crop. So we looked at all of the exposures that are in the peer-reviewed literature. This was over 500 studies that we looked through to look at exposure, again, in all application contexts. And what I'm showing you here is the field crops exposures of the neonics expressed as a proportion of the LOIC. So here's the LOIC right at 1. That's a proportion equal 1. So anything below that level means that there's, by definition, no risk to bees on any of these 3 responses, either impacts predicted to have had on behavior, impacts on physiology, things sort of suborganismal levels like cellular respiration, etc. And then again, this most important response for population dynamics, impacts on reproduction. So again, if the numbers come out below 1, no risk by definition. Conversely, if they come out above 1, by definition, that means that there is risk for impacts on either behavior, physiology, or reproduction. So where do the data come out? A little bit of a mixed bag, right? So some exposures, this is literally all the literature that has ever been published on this up until 2020 when we published this particular report. So now it's, I guess, almost 5 years out of date. But up until 2020, it was a mixed bag. The major finding for us in this particular section is that exposures were predicted to impact reproduction in 37% of instances around field crops fields, okay? So corn, soybean, and wheat. All right, so the question is, well, all right, that's great. So that's the concentration and what these researchers have actually found there. But was that concentration actually long enough to potentially have impacts? So first, let's look at that concentration. This is the study. It's from Jeff Williams, showing that pollen patties dosed with 5.12 nanograms per gram of thiamethoxam-clothianidin during the queen rearing period caused queens to have 34% less survival over 4 weeks, after emergence compared to controls, 38% less likely to lay eggs compared to controls, and then they had fewer viable spermatozoa in their spermathecae. So the question is, well, all right, this was over the entire queen rearing period. From the literature, it's clear that not everyone was, looking at concentrations of neonics over the entire queen rearing period. It could just have been 1 day of sampling. So what do we actually know about the duration of exposure to neonics around corn and soybean? Well, at about this exact same time, Chia-Hua Lin published a really nice study looking at what goes on when these neonic-treated corn seeds are planted in Ohio. So this is just in their backyard, right behind Ohio State University. And you can see all this dust that's getting kicked up, which we know has a lot of neonics in it from various scientific studies that have been done on this. So how long are bees actually exposed to neonics during corn planting? Well, that's what's shown right here. So this was 3 years of data in 2013, 2014, and 2015. The red portion of the bar is concentration of clothianidin and trapped pollen. These were pollen traps placed immediately in front of the honeybee hives. And then in orange is thiamethoxam. Okay, so those 2 exact compounds that we were just talking about from Jeff Williams' study. And as you can see here, there's a few things going on. So first of all, the duration of exposure is pretty darn long, right? So in 2013, it was 3 weeks straight of exposure. In 2014, just a few days. And then 2015, it was about 4 weeks long. So at least these 2 years, it was quite a bit longer than the entire queen rearing period. So very relevant that we're looking at these particular exposures and putting this LOIC risk assessment, to the test. Where is the level for the LOIC? Well, that 5 parts per billion is right down here, right? So each of these years, that level or the LOIC was exceeded for multiple, at least days, and sometimes multiple weeks, okay? So frequently, again, longer than the queen rearing period. And we also know that these exposures aren't just sublethal, they're also lethal as well. So this is data, again, from Chia-Hua's study showing that just looking at the number of dead bees that were accumulated in front of her colonies out in these particular environments, she could relate that very closely, explaining more than 70% of the variation to just clothianidin concentration in the pollen that they were bringing back. So clearly this pollen is pretty hot, and it's causing them not only to potentially have sublethal responses that cause the queen to not do well, but also actually kill some of those workers as well. All right. So there's some, data showing the risk assessment approach. What I would also say is that we have multiple other data sets showing that it's not just estimating risk, to bees that we can do sort of, in math space and show that there's real risk to bees in the United States. We can also look at longitudinal trends of populations of wild bees, which my colleague Melissa Guzman, who just moved into the office right next to me in the Department of Entomology here at Cornell, she has now shown that literally hundreds of species of wild bees are declining in the United States, and it can be directly linked to pesticide use, especially neonicotinoids and pyrethroids. You can see, especially here in the Corn Belt area, so this is why we're oftentimes focusing on field crops, but it's also other places as well. So for example, out in California, you guys have that thing called the Central Valley where all of our fruits and veggies are grown. Well, there's actually quite a bit of neonic and pyrethroid use there that is contributing to these declines of hundreds of species of wild bees across 6 different families, including the mining bees, Andrenidae, the apid bees, the cellophane bees and melitid bees, the sweat bees, and the leafcutter bees. Okay, and you can just see the declines in occupancy and how all of them are negative, and for 3 of the families, it's significant. This was a survey of 1,081 species of bees that Melissa put together for this particular analysis. Really just a super impressive analysis and one of the more impactful studies that's been published on this topic. It was published last year. Okay, so when is there risk? Pretty frequently, again, during crop pollination and also during field crops usage of neonic seed treatments, especially. I could do a whole talk on neonic seed treatments. If you guys were at ABF, I actually did do a whole talk on neonic seed treatments. Happy to talk about that further. Okay, so let's wrap up for the last 5 to 10 minutes or so, talking about information and disinformation. So I'm going to relay a few stories about the science industry policy interface that I've experienced over the past few years, which have sort of opened my eyes. I used to be a naive scientist thinking, hey, everyone just trusts data, right? Well, turns out that's not the case. Okay, so in September 2022, I was asked to give public testimony to the New York State Legislature regarding our risk-benefit report. So here is me sitting in front of a whole bunch of people with masks on because it was still September 2022 and we didn't want to get COVID. Well, we still don't want to get COVID. Yeah, my mask use has gone down a little bit. I'm guessing yours has as well. All right, so here's our report. Right before I got up and gave testimony, there was a person from Bayer. I'm not going to call him out by name here. He might actually be on this call right now, though. And his comment on the Cornell report was, it was incomplete. In the absence of a defined approach, they just said, there's the presence of a neonicotinoid, there must be an effect. That's not risk assessment, that's presence equals hazard. If that were the case, none of us would be drinking caffeine. Caffeine is 10 times more toxic to humans than neonics, but we drink it every day. So I don't know what he's talking about with caffeine. I guess I used caffeine as an example early on too. I really have no idea where he was going with that one. But the important part is highlighted in yellow here, right? He has called us out and said that actually we didn't do a risk assessment in our report. They just said there's the presence of a neonicotinoid, there must be an effect. All right. Well, let's look at this again, right? So is this presence equals hazard? Am I just saying yes or no? There's a neonicotinoid there? Absolutely not, right? There is presence right down there, right? There is real neonicotinoid levels right here, but we have done a quantitative risk assessment. This is presence that does not equal hazard, okay? So why did that person from Bayer get up there and lie about our report? Because he was trying to undermine the science and sell more neonicotinoids. It really is that simple. Okay. I tried my best to explain why his critique was unfounded, but as you can imagine, trying to do this without a PowerPoint presentation and explain to non-scientists, while you're giving public testimony, pretty difficult. The Birds and Bees Protection Act failed in the New York State Senate in early 2023. I think actually his tactic was pretty effective. And I think similar disinformation tactics are pretty effective in various walks of life nowadays. Okay, so in mid-2023, numerous legislators felt the bill needed another shot because it was based on sound science. And numerous op-eds started appearing in the media in fall 2023, this exact same time that, okay, maybe the legislature is starting to think about science again. One of those op-eds was from someone named Dr. Henry Miller, and it was written in the New York Post. Here's the title of it: New York Farmers' Futures Depend on a Single Hochul Decision. And actually got quite a bit of comments, so 47 comments. Really interesting to look through those comments as well. Henry Miller has never researched neonicotinoid insecticides, but that didn't stop him from saying this. So activists misled legislators with a single Cornell report from 2020 with serious credibility problems that implausibly concluded neonics are unnecessary. Its flaws included the absence of any new research, confusion about key concepts such as the difference between toxicity and risk, reliance solely on lab studies rather than real-world field data, and the failure to understand the difference between systemic and foliar uptake. It also lacked any consideration of actual pesticide use patterns by New York farmers. I don't probably have to tell you that all of that is a lie. If you would like to see, how that's actually a lie, you can go and look at these particular pages right here, where I've detailed all of how every single statement that he made there is untrue. So we contacted the Post to ask if they would just publish a factual correction, and the New York Post declined. At this time, I contacted Cal's Marketing and Communications, so that's at my university, Cornell, and I had a relatively large following on Twitter at that point. I've since gotten off of Twitter because it's filled with lots of other disinformation right now. Again, this disinformation permeating our society right now, which is really a disease. But anyways, I contacted Cal's Marketing Communications. They suggested I post to Twitter. So here's what I wrote. Dear editor, and again, this was approved by Cornell, what I wrote right here. Dear editor, a recent article in the New York Post by Henry I. Miller claims that our report, Neonicotinoid Insecticides in New York State, Economic Benefits and Risk to Pollinators, has serious credibility problems due to 5 scientific flaws. I'm writing to say that simple facts, which anyone can read by clicking the report to our link to our report, discredit Mr. Miller's claims. After going through those, in just a paragraph, I say, there you have it. 5 supposed scientific flaws in our report, 5 succinct explanations why Mr. Miller's claims are baseless. The pesticide company Monsanto previously drafted an industry-friendly article for Mr. Miller to publish under his known name. One has to wonder if a pesticide company drafted this disinformation article for Mr. Miller as well. So it turns out that Henry Miller actually did have a report drafted for him by the pesticide company Monsanto, and you don't really have to go very far to find this. You just have to go to Wikipedia, which refers you to the New York Times article where they documented this was true. So he had Monsanto draft a report for him for the journal or for the magazine Forbes, and then Forbes eventually retracted that once the New York Times pointed out that actually it wasn't Henry Miller who wrote this, it was Monsanto. So I guess the question is, was this post op-ed ghost written by a pesticide company? I have no idea. But regardless of who wrote the article, its content makes sense if you consider economic benefits to industry, not economic benefits to farmers. Okay? All right. So at the end of the day, evidence won in this case. We did pass this Birds and Bees Act in December 2023. This makes New York the first state in the USA to ban neonic treatments on corn and soybean seeds. We're not the first place in the world to do this. Ontario and Quebec, those 2 provinces, and Canada have banned them long ago. as has the European Union. But this is the first place in the United States that has now done it. It will go into effect January 2029, so not very soon, right? There's going to be quite a bit of time between now and January 2029. But in that time, New York State did something that I think was really smart. So they allocated $2.2 million to the New York State IPM program to develop and evaluate predictive tools for corn and soybean seed pests and also neonic alternatives. So we are now heavy into that right now. And we have the largest network of trials going on, in any state that has ever done this, where we're putting this in front of farmers so they can actually see how neonics are performing compared to untreated seeds and then some of these alternatives to neonics. So I'm really excited that New York State has done that. All right, so will evidence continue to win in other states on this topic or any other topic regarding pesticides? I would say that's largely up to you, right? So I can play some role here in terms of trying to communicate some information, potentially pass along some science, but I'm not an advocate. I'm a scientist. I'm just trying to provide the data that other people can choose to use how they like. Vermont followed New York's lead in June 2024. Other states are currently considering similar bills. I just gave testimony in Connecticut, and I believe California is considering some sort of bill along these lines. I don't know any of the details. You guys might know more than me. Okay, so I think, yeah, that leaves a few minutes for questions if you guys have any of them. Thanks again for having me join here. I'll just put a few smiling faces up here and say, I guess three things regarding funding. We've had some good funding from USDA on this particular topic. New York State is the agency, meaning again me as a taxpayer and anyone else in New York State who funded the neonic risk assessment. And then we've also had some good support from the One Hive Foundation, which is getting some good support out there for scientists and beekeepers on this particular topic and others. All right, thanks very much.
Thank you. Thank you very much, Scott McArt, for sharing some facts with lots of evidence to back up those facts. And I acknowledge your courage to defend those without a voice, our pollinators. And I also want to acknowledge your sense of justice on being a champion for justice on behalf of all of our pollinators, really. I certainly learned a lot, and I also learned how much I don't know. So I'll be certainly checking out some of these valuable little tidbits once you send us your slideshow in more detail, just to further galvanize my understanding, because I want to take some action. You've inspired me, and for that I'm grateful. Thank you. I want us to always have pollinators. I want to always be able to enjoy the diversity of food that we currently enjoy without a big deal. So thanks. And at this point, I would like to open the floor up to anybody. If you would like to ask Scott a question, please click on the raise hand button, and we will address your question. Thank you. And thanks to Kian for helping in the background with this, the camp co-manager.
My pleasure.
Thanks, Bunny. That was very kind of you. Thank you. Okay, it looks like we have a question from Musante Farm.
Yes. Doesn't include glyphosate.
Hi,
Yeah.
Scott. Thanks for your presentation. I love your research. I've been following it for quite a long time. I actually put probably like 10 questions in the chat. Quickly, I was just wondering what the chemical, and I can't pronounce it, butoxide
Yep.
is and what farmers are using it for? And also, is there any relevant information on the impact to a colony versus in adults versus pollen?
Sure. So it's either piperonal butoxide or piperonal butoxide, depending on how you want to pronounce it. Like any pesticide that's out there, there's a lot of people that pronounce them different ways. I don't know if there actually is an established way of pronouncing it. So it's an insecticide synergist. The most common place that most people will be familiar with it is in wasp sprays. So the can of Raid that you have, that typically will have pyrethrins and piperonal butoxide in it. It is used as, so what does that do? That piperonal butoxide is a P450 inhibitor. What are P450s? They are your enzymes that detoxify things. So if you inhibit those enzymes, all of a sudden you can't detoxify things as much, and therefore that particular toxin becomes much more toxic, pyrethrins, neonicotinoids, whatever. Growers will use it for agricultural uses for this exact reason. So it will oftentimes be included in agricultural sprays, or it will be added to a tank mix to put more efficacy in a particular active ingredient. I have been hearing, I do not know if that, so let me just qualify that I do not know if this is true, but I have been hearing that it is potentially being used as one of those inert ingredients more broadly in pesticides that are being marketed over the past 5 to 10 years or so. Again, I do not know if this is true, but if it, I guess I suspect that is true because of the increased quantities that we're getting of piperonal butoxide in almost every single sample that's coming through our lab. Again, we process about 2,500 samples per year in our lab, so we see a lot of sort of changes in contamination over time. And this is definitely something that has just increased rapidly over the past 5 years is the amount of piperonal butoxide we're seeing. So again, let me just qualify for a 4th or 5th time now that I do not know if that is true, if it's being included in these inert ingredients, but if it is, that would make sense to me. Okay, so what are its actual effects directly on bees? It's pretty inert, I would say, in its toxicity to bees on its own. We have tested that in our lab, and there are many other labs that have tested that as well. I would say that that's true, that it really is relatively inert on its own. It is really used sort of in combination with things, and that's when it doesn't become toxic itself. It just causes the insecticides or other toxins to become more toxic.
Thank you for that, Scott. Anthony has asked quite a few very informative questions really in the chat. Going from beginning with the effects of adjuvants and surfactants to if you've discovered or done any research on drone semen, and then a political question just to round it all out. There is word on the street that perhaps the EPA will overrule the states that are recently passing or have passed this neonic legislation, and we're just curious about those comments, if you have any.
Okay, so a lot of questions there. I just opened up the chat to look at this. So yeah, Scott, do you look at adjuvants or surfactants that are also part of the pesticide application and any synergistic effects that they may have? We have not, we can't do everything in my lab. So we have mostly just been looking at the active ingredients and some of the breakdown products. We have not looked at some of the adjuvants like organosilicones or other things that are in there. And we have also not been looking at surfactants. There are some folks, there's one researcher in particular in the UK who's been looking at surfactants. And as you might guess, when bees are directly coming into contact with the surfactants that are in sprays, they absolutely can cause mortality or sublethal responses in those bees. I mean, basically it'd be like, soaking us in a pile of soap. Not too bad for us, but bees happen to breathe out of their cuticle, right? So they breathe out of their skin, and if that gets gummed up with surfactants, probably not surprising. But that's direct spray. It's not necessarily the surfactants that they're picking up that have just been hanging out on flowers. It's really direct sprays that seem to be having the major problems for that, or leading to major problems. In terms of adjuvants, probably the leading researcher on this right now is Diana Cox-Foster. She's at USDA out in Logan, and she's been looking particularly at organosilicones, which are a very common adjuvant that are put into pesticide sprays. Like almost every spray has some organosilicones in it. And she has sometimes found that they are harmful and sometimes not, and sometimes that they interact with other stressors, such as other pesticides or pathogens. She's also looked at things like, interactions between organosilicone exposure and DWV levels in bees, for example. So I would say absolutely that they're not, always benign, but also that they're not always harmful, at least in terms of the data that's been shown to date.
Anthony was wondering about if you had the opportunity to do any research on drones. Could they tolerate higher doses because they're larger, etc.? Yeah.
Yeah, we haven't done any studies in our lab on drones. We have done them on, we've artificially reared queens. So this was Diana D'Souza, who is now at BASF. She's very good at doing, bee bioassays in little microplates. I think that's actually what she's mostly doing at BASF right now, hopefully trying to get us some pesticides that are not as harmful for bees as some of the current ones that are out there. But she was also very good at feeding them a lot of jelly and turning them into queens. So we have some unpublished work right now. It was the last thing Diana did before taking off, showing some impacts of fungicides on queen development. Why we're particularly interested in fungicides is because those are the dominant pesticides that bees are exposed to during crop pollination. I didn't present any of that research here today because there's only so much time, but some of the stuff that we're finding with fungicides is a little scary.
And have you heard anything about, I mean, nobody can predict the future, but are you confident that the laws that have been passed are sticking? Yeah.
I am not a politician, nor
Yeah.
am I do I have a magic wand? I have no idea. I haven't heard anything that,
Yeah.
the federal government would overrule states on this particular topic, but I really have no idea.
Yep. Yeah. Yeah. What can we do, just as Joe Public? How can we support the endeavor to protect our pollinators going forward? What can you name 3 pretty basic things that we can share with our neighbors, even if we're not beekeepers? Maybe we're master gardeners. Maybe we're just really concerned about our environment. Maybe some of us want our grandkids to be able to know what a bee looks like, that type of thing. Any
Sure.
words of
So I
wisdom?
think a key here, and maybe this didn't come across too much in this talk, I probably should have put an extra slide in or so, but a key thing here is that pesticides are an important part of agriculture nowadays, right? The vast majority of pesticide use is in agriculture. It's not in homeowner use. It's, I mean, if you want to talk about neonicotinoid insecticides, it's actually just on corn and soybean seeds. That's where the vast majority of neonics are used. But the use of pesticides is not going away anytime soon, right? So I think there's a lot of people who just want to abolish pesticides altogether. That's just unrealistic. But what is realistic is more judicious use of pesticides. So if there's anything that I would suggest is have conversations about IPM. Everyone knows, I think everyone knows what IPM is, right? Integrated Pest Management. Any IPM program includes pesticides, but it doesn't use pesticides prophylactically. It doesn't just, coat seeds in pesticides before you even know a pest is going to be there, and then, plant them in the ground. An IPM program should ideally use pesticides, but only when they're needed. So if you're a farmer yourself, or I mean, actually here, let me just relate it right to beekeeping, right? So do you guys monitor for Varroa before you apply a miticide, or do you just prophylactically treat, assuming that you have high levels of mites? Hopefully you monitor, right?
Yeah.
Because you are doing harm, number one, to your bees if you just prophylactically treat, right? There's no miticide that isn't going to have some, non-target effects on bees. Hopefully they're fairly minimal, but there's no miticide that's going to have no, impact on your bees. And also, if you continually prophylactically treat, the mites are going to develop resistance to whatever you're treating them with, especially if it's amitraz, which I'm guessing pretty much everyone on this call treats their bees with, if you are a conventional beekeeper and use, synthetic pesticides. The same is true for other types of agriculture, right? Non-honeybee agriculture, where we're trying to, control pests on crops. These pesticides are a really valuable tool, but if you just use them willy-nilly, they can do more harm than good, especially to non-target organisms. So yeah, I guess that would be my first thing to say. The second is be wary. So I'm consistently very wary when I talk about taking tools away. So the neonic law in New York is taking a tool away. How would you guys like it if I took amitraz away? Probably wouldn't like it all that much, right? So it's a real big thing to potentially take a tool away. And farmers really feel that. If I was a corn and soybean farmer right now who had been using neonic seed treatments for the past 20 years, I would feel personally threatened if someone was taking away that tool. So there is no way I'm going to even suggest that we should take something away unless I'm extremely confident that taking away that tool is going to do very minimal harm or no harm, to individual farmers, and it's going to have a very strong positive impact on non-target organisms. That is the case for neonicotinoid seed treatments on corn and soybean, but it is not the case for the vast majority of other crops that are out there. A lot of neonic usage that's out there has pretty darn good evidence that there's economic benefits for farmers. And if it's not just neonics, well, including a neonic in a pesticide rotation can be really good, so you don't actually develop resistance. So be very careful, I guess, about taking tools away. Be confident in what you're doing and hopefully do something other than just take a tool away. Encourage people to use IPM, etc.
Yeah. Yeah. Good answers. Thank you for that. Two more questions before we end. I would ask Musante Farm to unmute and ask your question to Scott, please.
Yes, Scott, I have a question. I know your research, you have explained why you don't survey for glyphosate. I think that would be relevant to explain to people here. And I also just had a thought. I'm also an organic pastured chicken farmer as well as a beekeeper and a breeder. So in the last couple of years, the chicken feed has had glyphosate levels that have been off the scale, way beyond the EPA limits, and they actually resulted in chickens stopping from laying their eggs. And I actually raised my chickens organically. It wasn't supposed to occur in the chickens that are fed organic feed, but my chickens also stopped during that time. That's another issue, but it just occurred to me that perhaps the declines and the high losses that we're seeing in the commercial beekeepers in particular this year, I'm just wondering if there's any usage of the same types of proteins that are in chicken feed that could possibly be within, say, the pollen substitute, and that maybe that might, on a rare chance, have some sort of role in this at all.
Yeah, so glyphosate, all right, so there's a lot of questions there, but let me first just address why we don't actually test for glyphosate. It just requires a completely different analysis, so a different extraction protocol and a completely different analysis on our machine. It doesn't mean that we shouldn't test for it. It's just that it's going to double the cost of actually doing, you know, the quantification of that particular compound compared to the other analysis, which I can, you know, survey for 105 pesticides simultaneously. We've been consistently requested to develop a glyphosate protocol. The FDA has one in their lab, private labs have it in their lab, and they do this, you know, for an added fee, because it's just a very unique compound for quantification. We still haven't done it yet because we have a backlog. We're now up to a year-long backlog in just trying to get processing samples, you know, through our facility. So we haven't devoted the time yet to developing a glyphosate assay, but we likely will, you know, in the future. All right, so there's the analytical side of things. In terms of the actual risk to bees from glyphosate, the vast majority of literature, as in 90% of the literature, and there is a fairly extensive literature on this topic for bees, shows that glyphosate is pretty non-toxic to honeybees. That doesn't mean that all of the studies show that it's non-toxic. It just means that, you know, about 90% of the studies show it's non-toxic at environmentally realistic concentrations. It is an herbicide, so it's not an insecticide. For that reason, you would also expect, well, it's probably not very toxic compared to something like a neonic or a pyrethroid. And of the studies, of those 10% of studies that actually have shown it could be potentially toxic to bees, it's impossible to rule out something else in the formulation. So it very could well be that an adjuvant or, you know, like a surfactant or something else in there could be responsible for the toxicity, not necessarily glyphosate. So I guess for that reason, we haven't really pursued it that much as something that really is driving risk to bees out there. But it certainly doesn't mean that, you know, hey, give it a free pass. You know, you don't need to worry about it. It's just that to date, the scientific evidence suggests, at least for bees, it's not that big of a deal.
Thanks for that. Thanks for that information. And finally, what is the number one issue with bees? Anthony asks in terms of their ability to deal with and possibly filter pesticides out of their bodies. Is it depletion of fat body in the bees? Or is it viruses and the eventual inability to be able to deal with those pesticides? What are your thoughts on that?
So, you know, I started out this talk with that slide with, you know, the 5 major categories that you know, are causing problems for bees. And there's more than just 5. Those are just happen to be my 5 that I think are the most important. But there's a list of 20 that, you know, you could come up with that are, you know, major issues. I guess what I didn't convey there is that those stresses don't happen in a vacuum. The most research that we have on the topic of pesticides and interactions with other stressors is with the varroa mite and viruses. So we can show in study after study after study that if a bee is parasitized by the varroa mite and it is dealing with some of the viruses, you know, that varroa is transmitting, that bee is more susceptible to pesticides. Likewise, if a bee is exposed to pesticides, it is more susceptible to being impacted by the varroa mite, right? So my personal opinion, there certainly could be lots of other stresses that, you know, that are important, but my personal opinion is, at least on the topic of pesticides, the most important interaction, just because varroa is everywhere, is the interaction with varroa.
Yeah. Thank you. Thank you for all of the information that you have imparted this evening. We're all the wiser for having attended this, and we wish you lots of fuel and enthusiasm and courage in going forward, because this is not always the most pleasant topic to research and discuss. So,
you have to be the adult in your room. That's absolutely true.
Yeah.
But this is an easy crowd. You guys are beekeepers. Tomorrow morning, as you guys can see, I'm in a hotel room right now. Tomorrow morning, I'm talking to New York apple growers, and that will be a tougher audience. So Yep.
We wish you all the best, Scott. Thank you so much for your generosity of time and all of your efforts that you're sharing with us, so we can be more informed in our science-based beekeeping practices. We thank you. Be
Great.
well.
Well, thanks again, Wendy, and thank you everyone for spending your, I guess, pre-dinner time with me if you're out in California.
Perfect. Perfect. Thank you so much,
Great.
Scott. Bye
Okay,
now.
have a good evening.
Thank you. Bye-bye.
Cool. Do we need to discuss anything or?
No. Thank you so much for being here. I'm really
Thank you.
grateful.
Nice job. Great. I didn't think
Um,
it was gonna. Wait, let me also end the recording.